Hello, in this video we're going to do a quick proof by contradiction of the statement that ax to the k plus b over x to the k is bigger than or equal to 2 root ab, where in this statement all of the parameters x, a, b, and k are real numbers, and also x, a, and b are going to be positive real numbers. So let's get on with the proof, and as with any proof by contradiction, we are going to start by making an assumption. So what we want to assume is the opposite of what we're trying to prove. And in this case, what that means is we're assuming that there exists some real value, real positive value of x, and some real positive value of a, and some real positive value of b, and also some real value of k that make this statement false, right? So we're assuming there exists this combination of parameters such that ax to the k plus b over x to the k is less than 2 root ab. And we're going to follow this through and see what the logical consequences of this assumption would be. So firstly, note that we've got an x to the k on the denominator of this second term, and so we could get that out of the denominator by multiplying everything up by x to the k. Okay, and so our first term is going to be a times, I'm going to write it as x to the k squared. Then the second term is now just b, and on the right-hand side, we get 2 root ab times x to the k. Note that we've used the fact that x is positive, and hence x to the k is positive, because we've multiplied up by x to the k, right? If x to the k were a negative number, then we would have had to change this less than into a greater than, okay, because it's an inequality. So let's tidy this expression up a bit by putting all of the terms on the same side. So we're going to get x to the k squared minus 2 root ab x to the k, and then plus b is less than 0. Sorry, I forgot the a in front of that x to the k, but now we're going to divide through by that a. We're going to divide through by this coefficient, and so what we're going to end up with is x to the k squared. Second term is going to be 2 root ab divided by a, times x to the k. Now what we can do here is, because a is positive as well, a is the same thing as the square root of a squared, right? So let me leave that second term like that for now, and the third term is just going to be b over a. That's going to be less than 0, and we can write this even more simply by noting that the square root of ab divided by the square root of a squared is just the square root of b over a, okay? And so the rest of this stays the same. And now, this is where something interesting happens. We can rewrite the left-hand side of this inequality in a very simple way, right? It's a quadratic expression. We've got this squared here. And we can complete the square on that expression. And it works out very nicely because the left-hand side is the same thing as x to the k minus the square root of b over a all squared. And that is supposed to be less than 0, right? So you can double check that that works just by expanding the brackets on the left-hand side. You get the first thing squared plus the second thing squared, and then twice the product of these two terms, which is exactly what we had in the previous step. All right, so what are the implications of this? Well, this is actually not possible, right? Because all of these parameters, x, a, b, and k, are real numbers, and you can't take some real number and square it and get a negative number, right? Because if you square a positive number, you get a positive number, but if you square a negative number, you still get a positive number. And so this is actually impossible, right? So we have a contradiction. We made our assumption up here, and we arrived at some impossible statement, and therefore we've got a contradiction and our assumption must be false, right? So I'll just write down there is a contradiction, and our assumption must be false. If the assumption is false, then this statement that we're trying to prove up at the beginning, that must be true. Okay, so there we go. We've actually finished our proof by assuming the opposite is true, and showing that that implies something which is just impossible. We've shown that this original statement must be true. So let me just put a little QED down here, and we're done. Of course, another way you could do this is by taking this expression up at the top and differentiating it with respect to x and finding the minimum value that way. Okay, if you differentiate this left-hand side, ax to the k plus b over x to the k with respect to x, and you find the minimum point of that, you would arrive at the fact that the minimum value of that expression is actually 2 root ab. So there's another way we could approach the same problem.